assessment that's coming up. This is actually an old surveying technique. Yeah. If I have a pond, and in this pond, so here's my pond, and I want to know, okay, so how wide is my pond? What we can often do is I'm going to, from this point, draw a line straight out. From this point, I'm going to draw a line parallel to that. So those are my two extremes, right? And then to measure this distance here, there's a little bit more geometry involved. I'm going to show you what they would often do. They would pick a point out here, some random point. Sometimes it's directly in the middle, sometimes it's not. They just pick a random point, and they draw the two. And then what they do is they ask ourselves, okay, what is that angle here? Okay, now, this does not look as bad as it seems. Well, actually, it looks worse than what it seems. But here's what's going to happen. Let's suppose I told you that this is 34 degrees, and this angle is 62 degrees. I want you guys to help me out here. How would you solve for x? Add them all up and set it equal to 180?
No, like put them all in the same equation and then equal it to 180 and then solve it.
No. I want to hear your thoughts on this. Okay. I gave those to you. Those are the givens. So where do we go from here? Christian? Okay. Now you're reaching into Egyptian mathematics. Do this and you get the result. The transition to Greek mathematics is, okay, if you're going to do that, why are we doing it? So why are you adding 34 and 62? Three sides of what? Or angles? Angles of what? If I just had three random angles, do they always add up to 180? Okay, so in what instance would it add up to 180? In what instance would it add up to 180? Well, that's one option. Or if it forms a triangle. Okay. Guys, come on. I know you guys are a little disengaged right now, but I want you to come back to this. Keenan.
Something or supplementary.
Yes and no.
What?
Yes and no. You're right, but you're wrong?
Makes sense.
Yeah, totally, right? All right, so I want to try something else here. I want to take this line and I'm going to extend it. Wow, that's a heck of an extension. Okay, now hold on. Guys, stop the talking so you can focus on this. Okay. If I extended that line, what can you tell me about angle 34 and the angle formed way out here? It's the same. So this is also 34. What shape did I just create down here at the bottom? What do you guys know about the angles of the triangle? Add 180. So instead of solving for x directly, if I could solve for this missing angle here at the top of the triangle, how does the x relate to that angle? That equals 180. I'm going to give you a little bit of a shortcut here, a little foreshadowing. X is considered to be an exterior angle of the triangle. This is foreshadowing to the next unit. And it is equal to the sum of these two angles. So here's the shortcut to all of this. The true shortcut. The easiest way to do that is that the angle formed by these two lines is always the sum of these two angles. Every time. So you were kind of close. And therefore x is 96 degrees. Every time. you that the angle between these two lines is the sum of the angles formed with the parallel lines. Okay? And then, to complete this problem, takes a little bit of trigonometry that we're not going to get into. But this is a setup of what they used to have to do for surveying to do these large ponds. All right, so that's going to end our lesson. We do have 3 assignments you guys need to do for homework tonight.